introduction to React Universal JavaScript web applications. And first of all, this thing, that what is the proper name for that thing? There's this conversation about, is it universal or isomorphic? I'm going to use the word universal here because I think it's better, and it seems that the JavaScript community in general has started using the word universal, as in sort of relates to when Apple had the PowerPC and Intel processors, so they had the same code which ran on both. So the same idea here is that the universal JavaScript code that runs on server and on the front end on the browser. And the main reason I wanted to keep this talk is that I started looking at universal JavaScript, mainly React, somewhere around last summer or somewhere there, and it was a bit bumpy road to start, and it was the ecosystem was quite in a lively state, let's say like that. And it always was that when I start, because I didn't have any previous really proper experience on like anything about like this universal JavaScript. So when I started looking at it, Googling stuff out, and anyway, so most of the articles and examples and tutorials I found were like really specific on certain implementation. And it was just about like first install these 100,000 different dependencies and then read this configuration. And then the examples were, many times it was that the example or the tutorial was written like 2 weeks ago, and then the dependencies were broken or something when I tried to install them. And then the tutorials were too simple or too complex. And it's pretty hard actually to grasp what it's about when you haven't done it before. So that's why I want to talk about this. And actually, the universal JavaScript thing isn't just React only thing. React does it, Angular 2 does it, CLICHÉ does it. I'm not exactly sure, but I think EMBER does it. EMBER has that fast boot thing going on. And then I know that RIOT, and I think I saw FRZR. FRZR has server-side rendering as well. So there are several libraries doing it. So maybe let's just look at like a bit higher level. Well, why write universal JavaScript applications? Well, the reasons are performance, because you get the something instantly to the user who's visiting your site. You get the server rendered UI, and while the user is watching it, the JavaScript client app is downloading and starting in the background, and it takes over. And then one big reason is crawlers. And well, Google understands something about JavaScript, but it's a lot better when you have a server rendered site. It understands it better, and well, other search engines maybe, but mainly social media sites like Facebook, PARSED, and stuff like that. So that's also a good bonus. And then users who don't have JavaScript, they also benefit from the site that has the universal rendering. And I'm going to go through the different stages of what universal JavaScript application is, or what it does when you're accessing a site which is done like that. So I like to start with thinking about routing. That's like always the entry point to the application itself. So when you visit a site, whatever site, but it's universal JavaScript, mainly I'm talking in the context of React here, but usually there's some kind of Node.js server who receives the response, and then it passes that receives the request, and then it passes that request to the, let's say, React router. And then React router checks that if it matches anything that it has been configured with, if there's any route match. If there isn't, you might have some redirection or error or whatever. But then React router receives that, and it decides what React components will be used to render an UI for the user. And once you know what components you're using, you will know what data you will need for the UI. Because that's the data fetching is one thing that was a bit confusing when starting with oops, isomorphic, almost said that, when starting with universal apps, because well, of course, in single-page applications, you're used to like making AJAX requests to some API backend and receiving the data. But those are asynchronous requests, and you can show spinners and stuff like that. But in the server side, that's the request is like sort of synchronous, so you have to have everything for the user ready, and when you send the response. So it was a bit hard to first, for me, I might be just a dumb person, but for me it was a bit hard to grasp on how to do those asynchronous data, I call them data dependencies, because they are dependencies, so that you can show the UI. So I saw a couple tutorials, and actually one of them was that the author was had configured like the data dependencies in two different places, in the React app, and then he had an Express app, and before the Express returns some response, he had like made some API calls in the backend, and I don't really think that's a good idea, because then you have in two different places the same data requirements. Then if you change your UI somewhere and you need to fetch some another data, you have to remember to put it into the both places. So that felt a bit silly. So at least in the and yeah, back to the router thing, that when you know what route you're accessing, that means you'll know what data you'll need, because you have the router parameters, and you know what components you are using, and maybe you have some information if you have logged in user, maybe you have some kind of information in the cookie, but with those you can decide what to do. And well, I sort of covered this already, that in a traditional server app application, you have to get everything before you can send the response. But the way you do that in React, or at least one way you can do it, is that pretty nice way of doing is that in React components, if you use ECMAScript next, I don't know if it's in it's not in a ECMAScript 6 specification, but you can use it with Babel ES next the ES class static properties. So you can define like what kind of a data you need as a static properties. Let's say, and you have a React component class, and then you have one static property of needs or whatever, and it's an array of saying things that you need to have. So then when you render server side, and you know what components will render, you can check the static needs of the component, and then just loop them and call them, every one of them, with the route parameters and possibly some cookie fetched information about the user. And then you can fetch that data, and if there are promises, you will have a array of promises basically, and then you can just use promise all and wait from all the promises to return, and then you can render after that. So that I think is a nice way. And then you can also, in the client-side app, you can use that same thing that you call that in, let's say, component will mount, you will call those static like data requirements, and then call them with the path parameters you receive, because I think the URL is the main thing that which defines what data you need. So path parameters are usually the most important thing what define what data you need. So yeah, and here's the most simplest server-side render thing happening. This is probably the only code I will really have, so I'm not sure if this is any credibility for me, but I try to keep the code as little as possible. But here's just the point that you have a small React hello world there, and then there's an actually handlebars template here, which you can render with Express.js, and here's an example that there will be like, this is something like, let's say, server.js, and it imports our little component. And then here, this doesn't actually say, but here before the actual rendering part, you would call those check what components you will be using for the render, and then resolve those data dependencies from there and call the APIs and get all the data. And then you will render, and it will output that hello world. Well, that's really simple example there, but that's the basic of server render. And okay, now the client will receive that hello world HTML from the server, and that's all nice, but that's sort of the first part of the thing. That doesn't have anything to do with the client yet. But in the build process, when we built the application, we used the same JavaScript code we used for creating the server-side app, and we bundle it somehow. I personally prefer Webpack. Pretty much it's quite nice tool. So you bundle a client-side JavaScript bundle, or bundles, depends how you configure, and then you send them with or you reference them in the HTML. And then when the client gets the HTML in the browser, the JS bundle will start downloading, and eventually it will parse, and at some point it will be executed. So if it happens that there's some problem with the, let's say the client doesn't have JavaScript enabled, or it's I don't know, some kind of crawler, the nice thing is that if you do your backend JavaScript right, that you use actually real links and put some time with the forms, so you can have a proper progressive enhancement experience, so that the user will be still able to use your site and navigate through it. And so after the client JavaScript is executed, it will take over the site, and after that all the links when you click it will be handled by the client side app. That's the basics of it. But there's one part there is called, I think this is the official term everybody is nowadays using, called rehydration. And that's the idea that when the server renders the response for the user, it has some state. It has calculated the state from the route parameters or maybe from cookies or something. But it had some. It's a stateless server, but at the time it processes the request, it has some state. So now we have to somehow pass that state to the client JavaScript app. That is called rehydration. And it's basically just, in its simplest form, it's just that we have some state, let's say some object. Maybe we have an object with message hello world. We just pass it, we put it into the HTML we send from the server and in a script tag, and then in the client-side app we read that to the client-side app, so it knows that okay, we had that state of message hello, which is a silly example, but that's how it sort of works. So you can pass it like information about logged in users or what have you. And that's the point, that the reason when you do that, you don't have to actually make those same API calls again in the client side. So if you don't do that, you basically have to fetch somehow calculate the new state again. So that would mean you have to make the same API calls you already did in the backend, which is complete waste. So that's why the rehydration step. And here's like a quick step-by-step of the universal web application. So it works as it starts with the server. You figure out all the data requirements. You make some API requests to your backend API. You figure out the data. You render some kind of a UI for the user. Then you send it to the user's browser. So now we're in the client. You'll have some HTML. Then the client app is parsed, it starts, and now, okay, the client is running, and then you can interact with it, and it will show you loading spinners and do whatever you interact with it. There's one step that what happens between the third and fourth step, that you receive some HTML from the server, but it might take some time when the client-side app is starting. Okay, if you did your application right using progressive enhancement, or like you make sure links are links and so on, the user will be able to navigate and so on. But maybe you have, the best example I figure out now would be some kind of a, let's say, form autocomplete feature. So you could have a small script that is listening for the input element, and when the user inputs something, it will record those key events, and then when the client app starts, it will replay those key events to the client-side app, and this is called PREBOOT. But this this is actually more of an Angular 2 concept, but I suspect it will be more like it will become part of another libraries as well. And I've been thinking that you might be actually able to sort of hack it together to React with, let's say, if you're using React with Redux library, you could do it so, or whatever. Actually, let's not mind about Redux, but in React, when the user is typing something to an input box, you could record those keys what the user is putting there, and then before the rehydration happens, you could inject those into the initial state, the JSON object that came from the server, and then the client app reads that, and it notices that there's some new user input. You could hack it like that, but I suspect there will be libraries to probably many React and others as well, but I think that's a nice little step there. So it looks something like that, that you handle some way you handle the user's actions between there, but that's not, of course, mandatory, but that's something you could do. Then just few random things I've come across while developing a universal JavaScript app with React. These are completely random side effects, because React, as I showed there was this express template there that the React app will fill that markup area and the server. But what about when you want to put something in the head, let's say like title and you know those meta tags for social media crawlers? Then there's a couple really nice libraries. React Helmet is actually from NFL, and it's pretty nice. You can handle all the social media tags and titles with it, and it will update in the client as well, but it will also handle the server-side thing. If you need to do something fancier, you can use the React side effect, which actually the Helmet uses. We have this data layer JSON thing that we have to put on every page. So probably some of you have also used data layer. So I use actually the React side effect to define the data layer. So I have React components that just say something specific about itself, and then it all merges down to a big JSON object that gets put into the page. And then I started sort of from this might be like silly and simple, but when you've done a lot of single page applications, the context switch can be a bit hard sometimes. You easily start to think about in the way of single page apps, that in single page apps it's easy that you get some authentication token for the user. Okay, now you have to authenticate your API calls. So you might put it in the API libraries have these called interceptors. So you might store it in an interceptor, and then the out token is with every API request. Well, I did that accidentally on backend. That's not a good idea because that meant that all API requests had the one token from one user. So that's not a good idea. So try to remember that thing. Be careful. Then time differences. This was actually funny. I had a thing that updated every few seconds. And then I was wondering why, okay, there's a server render and then the client render, and React notices that there's a difference in the HTML it's received from the server and in the front end. And I was like, well, of course it's not a big problem. React handles it smartly, but I really want it to be that it doesn't have to re-render there, that you can just directly start using that. So I noticed that there was of course, when the render happens on server, there's of course always a latency there. So that's one thing to keep in mind. Then this refers back to what I said in the start, that when I took some tutorials and ran them, there was dependency problems. So in the NPM world, I'd say always use that save exact true. So that always saves the dependencies with the exact version. And if you're willing to go a little bit deeper, then use npm shrink wrap, which sort of locks all the dependencies that your application's dependencies use. And yeah, this I already said. Then this is really useful when you're developing application that has both renders both in server and in client. It's a good idea to have some sort of mechanism to say that, okay, when you're developing, you only want to debug the server output sometimes, so you don't mind about the mind about the client output, or sometimes you don't want the server output anything, you just want to debug the client side. Maybe you want to use Redux dev tools or stuff like that, which works well on those. So those kind of a random notes, random tips and tricks. And then before I end, couple parting thoughts. Always ask yourself, do you even need a fancy universal JavaScript site? If you're making, let's say, some sort of internal tool, maybe you don't have to have the server-side rendering there. It simplifies things a lot, because building a universal rendering web app can be quite, well, there can be a lot of work there. So maybe it's easier if you do only single page app, if that is like, if that fits your requirements. Also, if your site is a blog or something, maybe just use WordPress or some static website generator there. So, and if it's a simple app, maybe some simple backend, and then, for example, Turbolinks library, which makes like changing pages really fast with Ajax and stuff like that. But always consider these. Then, universal web apps have been called many things. And one was probably holy grail of web apps or something. Not sure about that, but I think this pattern will be more common in the future. So definitely start looking into those. And that's about it. 2 minutes overtime. Thank you.